Hello guys, myself Sheikh Basha. I am from Mechanical Engineering. My rule number is 22955A0314 and my tech talk based on material engineering, and my topic is magnetic materials used in electrical machines, a compression and selection guide for earlier machine designs. Introduction. High efficiency electrical machines plays a key role in the ongoing ongoing concurrence to reduce the energy composition and to improve the efficiency of electrical devices. For the electrical machine design processes, an accurate understanding of the management material characteristics is a curricle requirement. General management data for a management material is available for the manufacturing data steels and database collections. The data is usually obtained extremely with EP-steen for EP-steen frame supplies or toroidal rings following international material characterization standards. However, store core of rotating electrical machines have an round shape, and those a different magnetic field and magnetic flux density distribution leading to different see, magnetization schemes and other iron losses hotspot. The first In the first part of the article, a broad overview and compression of possible magnetic materials for performance machines in presented. The investigated materials are listed in table 1 on the following page. For specialization material like extra thin high silicon iron SiFe, nickel iron NiFe, and cobalt iron CoFe alloys or compared together with soft magnetic composite SMC amorphous materials and the typical non-operated silicon steel lamin- lamination materials of grade M400-550A. Furthermore, a new evaluating schematic for an easier magnetic materials selected in inter introduced selection in introduced in this schematic. Both the magnetization curves and iron losses can be studied in the same diagrams, which leads to a facilitated material selection processes. The second part, material deterioration during the machine deterioration during the machine manufacturing process is disused together with healing possibilities by heat treatments. The material properties for the data stream can be significantly different compared to the properties of the final assembled machines. The stacking and wilding influence is available influence is evaluated experimentally for NiFe and SiFe materials. Experiments also show that the final heat treatment of NiFe and CoFe at specific temperatures and in a specific atmosphere is an indispensable to achieving advertisation magnetic properties for the high flux density demanding applications such as electrical machines. Magnetic material in electrical machines. The ferromagnetic materials such as iron Fe, nickel Ni, and capital Co constitute the basic variants, basic variants used in the manufacturing, of course, for the electrical machines. Their magnetic properties mainly depending on the atoms structures and the electronic configuration on the outer atomic shells, and its distance to the atomic nucleus. The physical properties can be improved by alloying them with other metals, and the typical magnetic materials alloying includes cold rolled motor lamination steel, thin gauge silicon steel, non-oriented electrical steel, 40% and 80% nickel iron alloys. Cold rolled motor lamination steel CRML. The cold rolled motor lamination steel belongs to the classes of very low carbon content steel with approximately 0.06 percentage of carbon, 0.5 percentage of silicon, and 0.6 percentage of magnesium, and lamination of 0.46 mm to 0.79 mm thickness. Then find their uses their and then find their use when the cost derives the design and requires higher values of saturation, flux density or permeability. The currently to the pore core losses properties in spite of the fact that the contemporary grains of CRML steel now exhibit loss characteristic competitivity with certain grades of grains of non-oriented silicon steel. The lack of substain, the lack of substantial alloying elements and abrasive isolation containing helps extend tooling life, resulting in additional saving in manufacturing cost. The application includes high volume of production of appliances motors, automotive motors, and alternator and industrial motors and generators. Thin gauges silicon steel. In thin gauges silicon steel, generally 0.25 mm and thinner reduces the thickness of the lamination material, and it resistivity to lower the eddy current losing, and those the overall core losses in and given lamination. The thin gauges silicon steel overall, the thin gauges silicon steel fall into the categories those with an standard silicon content of slightly less than 3 percentage, and those with an silicon content about 6.5 percentage. Their characteristics makes the attractive for special motors and power generating applications, especially those operations at high rotational speed. The standard chemistry steel find a place where lower losses because emanate while while incurring the least cost impact. The 6.5 percentage silicon steel, those being expensive offer lower losses and extremely low magnostructural characteristics due to their higher silicon content. No oriented electrical steel. The non-oriented electrical steel impromises to be an special steel with low carbon content and up to 7.5 percentage of silicon, and processor to produce provides for uniform magnetic properties both longitudinally and transversely. It inherits higher permeability, low average core losses, and good gauges uniformative uniformated through with cold finishing plaza strips enabling and smooth surfaces and reducing buckles and waves to result in extend exactly flatness and a high stacking factors of moderate silicon content, then alloys of reasonable long tool life to enjoy and wild varieties of motors and generating applications including service motors for motion control systems, aerospace accessories, hybrid and other electrical vehicles, electrical traction motor and industrial and public service motors and generations. Those there remaining fewer nickel iron alloys, alloying iron with nickel significantly reducing those core losing in the steel and market markedly improves permeabilities of materials. The nickel irons has a class of material providing the lowest losses of any steel commonly used in the rotating machinery. The two primary types of nickel iron steel used in rotating machinery are those with 48% nickel and those with about 80% nickel. The 48% nickel iron often used in motors with low loss requirement such as dental and surgical instruments operating in reg- regulated closely regulated the thermal ranges and in non-motive devices such as resolvers due to its really low structure flux density. 80% nickel iron field a place in resolver tachometers, and other feedback devices. The nickel iron steel required a very high temperature enabling accompanied by the interactions of an surface oxidizing oxide layer to develop their optimal magnetic properties. Material compression due to the structure efficient effects due to the structure effects in due to the structure effects in ferromagnetic materials, electrical machines are generally designed to work just below the structures. Their point of the BH magnetization curves as it is shown in the figure 1. However, since the BH magnetization curves is different for each magnetic materials, the machine generator has to be adapted to have an efficient materials utilization in terms of ohmic bending losses and the value and weight of the core. Material manufacturing provides in general typical magnetic and physical data of their lamination steel. Electrical machine designers can use this data in the earlier stages to compare different materials in terms of BH magnetization curves and iron losses densities. However, it is deflected to evaluate both par, parameters at the same time. Thank you to giving this opportunity to me.